All right, folks, we are live. And today we are going to continue our data visualization building on top of this data set, the 311 animal service calls, which I think is also here. Yeah, there we go. Okay, so if you have any questions, please share in the comments. If you want to join me live on screen or ask me a question via microphone or give me some suggestions live, I would recommend joining with this link right here. I'm going to post it as a comment under the YouTube video. So this link, if you click on it, you'll be able to join me directly in the session on StreamYard. All right, folks. So hopefully this is big enough for everybody to see. Let me delete this. We're using the animal, this number data set from New York City. This is a data set as a reminder for those who were not here in the last session. So you can see here the dates created when people called in to 311 in New York City to complain or ask a question about an animal or a pet. This is the agency name where the call was or the complaint was directed. This is the complaint type, and this is the descriptor. Probably the most important columns. With zip code. Zip code we're going to analyze as well. We should see that here in one of the columns. Right here, zip code. Animal waste, you see different descriptors here. You'll see animal waste, you'll see dead animal, pet / animal. If it's unsanitary animal or something about restaurant, bar, deli, pet animal, and food establishment that have to do with Department of Health and Mental Hygiene, that is most likely a pest. That's most likely a rat or a mouse that they saw in a food establishment and wanted to call that in. So I think what we should do is start analyzing this data. The community, we had a conversation on Charming Data right here. Let me go to Charming Data. A couple of hours ago at 9 a.m. Eastern time, and we talked about this data set right here. It was this event. This is happening right now, but the past event in 9 o'clock in the morning, we talked about this data set. If you would like to join us, we're going to have the same event next Saturday, and we'll talk about this data set and what we could do. So we talked about these ideas, right? So let's start analyzing this and executing some of these questions that we have as a way to dig deeper into the data. We're going to use Python, we're using Plotly, we're using Dash. Eventually we'll build some AI. But yeah, let's do this together. All right, so the first thing is geographical display of complaint type or descriptor by zip code. So we probably will build a corpus map for that. So here's what I'm going to do. We're going to focus on these two columns, either complaint type or descriptor, or both, we'll see, and the incident zip code. All right. So we need a corpus map. Let's go back to the data set right here. And what we're going to do is, this is our layout. So we're going to leave this all the same. We'll leave the callback. We'll just add another graph. I'm just going to build another graph here above this one. DCC. In fact, I think I have, well, we'll do that in a sec. Graph. We won't call it bar chart. We'll call it choropleth. Choropleth. choropleth map. That's the ID. And then we'll put in the figure. We'll put here the figure that we're going to build. So let's build a figure. Let's build a figure right now. We'll go here, unique complaint types. We don't need this anymore. Okay, here. We'll tell, I think I have here either Claude or the PyCharm AI completion. So we'll say build a Plotly choropleth map that analyzes. Let's analyze. What are we going to analyze? Let's analyze the descriptor first. Let's do the descriptor. And then we'll change it. The descriptor column. There we go. The descriptor column by zip code. But the zip code is called incident zip code. By zip code. Incident zip column. So let's see if it's able to do it. Autocomplete. Do fig choropleth, and then we'll do the data df. All right, let's do some autocomplete here. So let's do tab and see what we get. So locations is incident dip, color is descriptor. Okay, added some complaint type to hover name, added some hover data. For some reason, it's choosing a plasma color. Let's look how that. Let's see how that looks like. And that's it. All right, let's see. Let's see what we have. We're going to put this figure. We'll call it fig map. And we're going to put it inside our graph here. Here. Let's see what we get. Let's rerun this app. Disregard the other drop down on the graph. It doesn't matter right now. We're just going to focus on that. All right, so we have a choropleth map here, but something is not working, right? We see that we don't have any descriptor. The colors don't change. So let's look into Plotly, Python, and we'll look at the examples of the choropleth maps in Plotly and see what the AI did not get correctly. Choropleth maps. All right, so introduction, blah, 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 blah. Let's do by zip code. No one is doing zip code here. This they're using GeoJSON. No, but we want to do it by zip code. Okay. This one is using GeoJSON. Let's see. Interesting. No, this is not doing by zip code. Well, actually, it should focus only on the US. You know what I'm going to do? I'm going to go here. And in one of the codes that I built, I think I've done zip code there. So let's look at the zip code analysis. Where was it? Where did I put it? Ah, shoot, I don't remember where I did the zip code. Because I wanted to give you the answer right away, because I don't remember how I did the zip code. Maybe it's in announcements. No. All right, so let's go back to the PyCharm and see what's wrong here. So corpus map, we have incident zip as the zip code in locations. I think this is not right. So let's ask ChatGPT. I can go into the Plotly docs, but I'm just going to ask ChatGPT. We'll go to ChatGPT here, and we'll give it our data set. Load our data set. I think I can even pull it from here and drag and drop. Okay, it's in there. And we're going to say, I have this data set with zip codes and descriptor column. And I built a choropleth map for it, but it's not working. Oh, can you please help me fix the code? All right, let's see what it says. Or we'll just debug it manually looking at the, all right. We have to ensure that the incident zip code is the correct format. Strings instead of integer. Let's see what format it is right now. What do we have here? Looks like it's integer. And then it needs a geographical, it needs a GeoJSON that PyCharm did not come up with. Since zip codes are not directly recognized as geographical locations, you need to provide a GeoJSON file. Okay. Load a JSON file containing zip code boundaries. But I don't have a GeoJSON file. First of all, let's find this GeoJSON file. Okay. Oh, we can do projection. USA, yeah. Instead of, let's change the projection to Alberta, USA. Let's do that instead of American Terror. So just focus on Alberta. No, Alberta. Okay. Alberta, USA, complaint, incident. I think these are okay. Even the hover name, it doesn't matter. It could be okay. Locations, we might have to change this to a string, but we also need the GeoJSON file. So here, let's see if it can find me a GeoJSON file for zip code boundaries. Let's ask it. Can you help me find a GeoJSON file for zip code boundaries in the USA? Boundaries in the USA. Let's see if you find something online. If not, maybe I can pull it from the Plotly library. Using offers zip codes. Oh, there's so many different websites here that I can check. We can try this. I wish I could just pull it from the Plotly. So I could pull it from USA. Okay, here's USA, but this is using locations. I wonder if there's, I don't think there's locations in the data set of like, no, of course, because it's not states. It's just zip codes within New York. All right. So you know what I'm going to do? I'm going to actually Google it. Old school. Can you, no, let's see, find GeoJSON file of zip codes in New York City. See if we have something online. This is obviously not working, so we can close that. All right, folks, if you know a zip code, GeoJSON file of New York City, zip code based, please share it in the comments or on Charming Data. I'd love to use it. New York City. So here's where we're going to put our choropleth. Come on. Why is everything so slow? Probably because of the live session. Let's see if there's another one here. GeoJSON file for zip codes in New York City. And it's incredibly slow. What the heck? Kaggle. Let's see if Kaggle gives me something. Sorry, folks. Internet seems to not be cooperating. Hopefully it will load soon. Come on. I hope I'm still streaming because it seems like my internet is down. Can people still hear me? So weird. Let's see what happens here. That was weird. Okay. Zip code. Let me see what we have on PyCharm. Okay, zip code boundaries. That's an MD file. I can use city, county, FIPS. Oh God, I have to log in. I don't have a login. Just give me a GeoJSON file. Why is it so hard? Okay, folks, I'm going to need you to send me on YouTube some GeoJSON files. What is this? Oh, I can't do that. Let's see if Kaggle gives us anything. I don't know if this is going to work. I can give it a shot. Let's see if we do it raw data, if we can access it. All right, let's see. Oh, God. Raw file. See if it works. Now we do have to go and call that in there. Let's see how they did it in the documentation. How does FIPS? FIPS? No, we don't want that. Let's go back and say, use it this way. Let's load our file, see if we're doing this correctly. Do this on, and then we want to do this. And we need our feature key. It's going to be in the format of, oh, I can't see. I'm not sure what feature key the format is going to be in. Zip code, properties.zip code. Here we have properties. Do we have zip code here? We have city FIPS. We can try that. Let's do postal code. Postal code. All right, let's give it a shot. It's not as helpful as I thought it was going to be, but we'll give it a shot. Postal code, post. Yeah. No such file directory. Oh, God. Don't tell me I have to download it. Let's just save it. All right, let's see what it does now. Import JSON. JSON. focus on the USA. We should probably focus on New York City. I think we got it. Let's see. Come on. Oh God, my internet is so slow. Let me try to reload. All right, now that I close all the tabs, hopefully it's going to be a little bit better. We got it, folks. Everything is, oh wow. 12 animals is everywhere. All right, let's do an analysis. First of all, we have to focus on this choropleth. So let's focus into it. So we'll go to choropleth, and let's see if there's a zoom. I'm going to do Control F, zoom. Zoom into the map. There might not be a zoom with choropleth. So we're going to go back, and we'll look at the figure reference. We'll do, where's maps? Choropleth. And we'll see if there's a zoom or focus feature. Zoom level. No, we'll do focus. Or center. No. How can I zoom into or center and zoom the map into New York City? You need to adjust the map's layout geo, setting a figure layout, blah, blah, blah. Okay, here's a center. So there is a zoom into update layout. That should have been here. I'm not sure it wasn't there. Max zoom. Maybe it's in layers. Shape selections. That's so weird. It should have seen it here. That is so weird. All right, let's give it a shot. We're going to update layout. Fig map of the layout, new dictionary. This is the center of New York City. Adjust zoom level. Let's do 11. Visit. Okay, let's see what happens. All right, so we're building the corpus map. Whoopsies. Did you mean scope? Via C? I don't think there was a zoom function there. Let's look at the poly. Here, scope doesn't exist. Let's go to map traces, choropleth. Let's look at scope. Damn. Okay, how do we fix this? Map property zoom. Zoom doesn't exist. I think it's because it's a choropleth map. What happens if we just do this? In the meantime, while it loads, well, actually, it'll take a second, so let's just load it. Okay. Oh. It's supposed to load everything. What happened to this map? What? Why did visible false? Why did it do visible false? Visible should be true. We want to see the corpus around it. All the zones. There we go. Okay, so it's centered, but we need to focus. So we're going to say, ChatGPT, you're hallucinating. There is no zoom property. Can you use a different property in Plotly to zoom into the map? It might not be possible with Corpleth. Range? Oh no, this doesn't seem right. I mean, it seems like a workaround. I'll try it, but I don't think it's gonna work. I don't think that's possible. Ridiculous, I tell you. It just seems ridiculous. I'll give it a shot though. Ridiculous. Ah, it worked. Well, I'll be damned. So I can do visible false. Let's do visible false. All right, so we're only seeing New York City. Perfect. Now I want to make it a little bit bigger. This is too small for me. So let's see if we can make it bigger with this. I saw it at the very beginning. To remove the boundaries. There's a way to remove the boundaries of the map so it makes the map bigger. Wider and higher. Let's see what it says. With and let's give it a shot. Well, I'll be damned. That's pretty big, but that's fine. Can control it later. All right. So now we see that almost all of them are 12 dead animals. Now, the thing is that every zip code will have multiple things. It will have multiple descriptors. So what we want to do is see here it's telling us what's the maximum descriptor. Let's do an analysis of the descriptors. Let's do a bar chart. Let's build another graph. We'll call it bar. Do bar. Okay. And we'll build it bar fig. Not group by df, and the x will be the descriptor. Is it with a capital? Let's see if it's with a script. Yeah, capital D. What the heck? That ain't good. Oh, it's so light. You know what? Let's use a histogram. It's really hard to see the colors. All right, I'm going to plot it with a histogram. Let's let it refresh. Got our choropleth map. All right, yeah. So as we can see, 14,000 descriptors are dead animals, 12 dead animals, which doesn't make sense. It doesn't mean anything. 12 dead animals is kind of like a code name for something, because there is dead animal here and noise and farm. So let's, instead of doing the descriptor, let's analyze something else. We'll analyze the let's do agency name. Okay, let's see what we get now. An agency name in the histogram. Department of Sanitation, all right. But there's only 1, 2, 3, 4, 5 departments. That's good. Department of Health and Mental Hygiene, and Department of Environmental Protection. All right. Now let's do by complaint type. I don't think there's too many complaints. So we'll do facet row. I want to see how many are food establishment. So we'll do facet row. Histogram. Is it facet row or row facet? I can't remember the exact name. Complaint type. Ooh, that's hard to see. Let's do facet column. That might be easier to see. Okay, reminder, we're looking at this data set. I'm doing a histogram in Plotly. Okay, so the Department of Sanitation doesn't exist. We can see here. It only exists when the complaint type is, come on. Complaint type, illegal animal, complaint type sanitation. So Department of Sanitation only with the complaint type is sanitation condition. So this could be related to pest. All right. Let's look at sanitation here, see what we find. Unsanitary animal, unsanitary animal. You see, Department of Sanitation, sanitation condition, 12 dead animals. I really need to know what this 12 dead animals refers to. I wonder if there's another name for rats. Beautiful rats. Sanitation condition. You see, everything is 12 dead animals. You know what? Let's Google it. let's see what. What is 12 animals in 311 service calls? NYC. Let's see if somebody caught that. I'm going to need to highlight this as a keyword. It's not telling us. Let's see if ChatGPT has more information than Google. Assuming they don't hallucinate. Related to the animal removal. All right, it's going to be internal category code. Yes, for sure it's an internal code, but we don't know. God damn it. God damn it. Okay. Dead animal. So the Department of Sanitation is responsible for removing dead animals from public spaces. Residents call 311 for dead animals. Property owners are responsible for removing dead animals if it's a private property. Okay. Let's see if they have anything about rodents. I doubt it. Rodent. God damn it. Nothing about rodent. All right, so we know the sanitation condition, Department of Sanitation, 12 dead animals. Is this a dead animal on a sidewalk? It could be a rat, it could be a raccoon, it could be a pigeon, and the majority of them are 12 dead animals, or are dead animals. And that's why in our, does it say here anything? Unique key, 101872. Dead animals. 12 dead animals. Yeah, I guess it just means dead animal. Yeah. All right, good to know. Just keep this here just in case. Just a dead animal. All right, so that's why almost all of them here, the great majority, is dead animals. All right, so we want to do an analysis of the New York City service call, removing dead animals, maybe animal waste or pet animal. Let's do an analysis of this. Let's remove the dead animals and do a scatter map. Let's do that. All right. We're going to say, I'm going to tell remove the 12, whoopsie daisy, 12, what is it called? Dead animal column. Let's do that. Let's remove the 12 dead animal column from the data set. Remove the 12 dead animal value from the, I think it's descriptor, from the descriptor column. The descriptor column. All right, df equals df descriptor that does not equal to 12 dead animals. Yep, that makes sense. And now, let's stop this. I don't want my computer running. Build Lotley scatter map with the what are they called? Lat long, latitude, longitude. And longitude columns with color being the descriptor. We'll call it fig scatter. Okay, scatter. I don't want to use map boss. We'll do that for now. That's fine. Then let's clear this for now. And we're going to use the fig scatter and clear this for now. And this. All right, fig scatter. Let's see what happens. Okay. Beautiful. Absolutely pure white map. And it's probably because it's using the scatter map box. We do not want that, so let's go back. We need to, did we get any error? No error. Maps. Scatter map. Scatter plot. Well, I don't want a scatter geo. I just want a regular scatter map. I think it's this one. I think it's this one. Map Libre. Okay, scatter map. Lat long. Where is our map here? Okay. Latitude, longitude, descriptor. All right. DF. We do have zoom, so we can use that as well. We'll use OpenStreetMap. And it's just called scatter map. Scatter underscore map. And we'll use OpenStreetMap. All right, folks, let's see what we get. Is it going to work? Let's pray to God it's going to work. We're getting error. Fig is not defined, of course. Fig scatter. All right, so we have our longitude and latitude and longitude and the descriptor column. We're going to see a difference in colors. Let's see. And voila. Okay. Well, that's a lot of colors. So we don't have 12-lit animals. Oof. No, I don't like this. There's too many colors. I need a black and white map. So let's choose dark. Map style. Map style. Let's choose dark. Let's see if that works. Okay, it's a lot better. All right. Most of them are red and, well, most of the red are in Manhattan and the green are on the outside boroughs. So red, let's look at this, is pet animal food establishment. So this is probably rats and pests that we see in food establishments. You know what we can do? Double click on pet animal. Wow, there we go. All of them are right there. And then the green one was other animal. Okay. On the outside, there are other animals as a majority. And inside, in the outer boroughs. And inside, we have pet animal. Very interesting. All right, folks, this is a pretty good analysis. I like the map. If you have any other suggestions, let me know. But I like seeing that we have pet animal as red, food establishment, and the green are unsanitary animal. What? Oh, the descriptor. Oh, what's the title that we chose? Hover name is a complaint type. Okay. So we put complaint type. Food establishment. All the reds. Come on. The majority of the reds are food establishment. Food establishment. So pet animal and food establishment is the red. And other animals is unsanitary animal, private property. Not public, but private property. Okay, so if it's a restaurant, it's under pet animal, red. If it's a private property, it's going to be in green, other animal. That's so interesting how 311 codes everything. So this could also be like rats or mice or pests or cockroaches, whatever, raccoons, causing unsanitary conditions. This will be in green. If it's private property, it's going to be in green because 311 doesn't attend private property. But if it's a public property, like a food establishment, then it's just going to be pet animal. All right, so we're getting close to better understanding pests in public property, which is probably food establishment. Let's see if we have farm animals. Farm animals, as expected, are more in the outer borough. Illegal animal kept as pet. Illegal animal kept as pet. So any descriptive as a farm animal is an illegal animal kept as pet. That'll be an interesting analysis to see where these illegal animals are reported by zip code. All right. Okay, so we have illegal animals that are farm animals. Animal odor is an unsanitary animal facility. So it could be like a shelter. What street is this? Yeah, this could be like a shelter or something. What is in here? East 110th Street. This might be a shelter. Not sure. Unsanitary animal facility. Okay, that's interesting. Animal waste. People call in when they see animal waste. That's interesting. Animal waste. That maybe poop on the ground? That's kind of weird. What kind of animal? Oh, it's all like animal in the park, animal in the park, animal in the park, and unsanitary animal facility. All right. So we're going to focus on pet animal because that's in public places and usually food establishments. Let's confirm that all pet animal descriptors are actually food establishment or vice versa. So let's see what the relationship between food establishment and the descriptor. So the relationship between the complaint type and descriptor. So we'll do here. We have this histogram. I wonder if we can see it this way. We'll do the complaint type will be the x-axis. Maybe we can see color. as descriptor. Let's see. Oops, we got to show it. Let's show it here. All right, so descriptor, we have animal in the park, unsanitary. What was it that we were looking at? Food establishment. Food establishment is red. All of the red is pet animal. Interesting. All right, so now we see there's a correlation. Very interesting. Food establishment is always, any complaint type that is food establishment is always pet animal. Any complaint type that is unsanitary animal in private property is always, the descriptor is always other animal. A dead animal is always accompanied by the descriptor of, the descriptor of dead animal is always accompanied by highway condition. And noise is accompanied by noise. Illegal animal is as a complaint type is always a farm animal descriptor. Illegal animal sold is also a farm animal. Only here we see two combinations. Unsanitary animal facility could be a shelter, a zoo, a small zoo, whatever. Maybe a chicken coop in a community garden. It either is animal waste or animal odor. All right, so this is probably pests and rats and stuff like that. I'm assuming it can't be anything else. Cameron, what turned out very well? I don't understand your comment. The app that we built. All right, so food establishment. So let's do an analysis of food establishment, meaning pet animal is the same thing over time. Let's try and do that. We have here all our choropleth. This is over time. So let's see, do we see here animal in the park? Food established, here we go. Oh, so we see that from 2019, or 2020 really, 2020 all the way to probably 2022, very, very low. The reason this is very low is because this was COVID, right? Yeah, this was COVID. Let's actually mark this as COVID. 316 we'll mark as COVID. So let's do that. Go to Plotly. And we're going to go to shapes, or not annotations, but what is it called? I don't think it's shapes. I think it's more like maybe it's under shapes. I just want to draw a line, a nice line. There we go. Let's draw this line right here, and we'll call it, and we'll say COVID started, COVID-19. So this is on 1 to 2. What is it? Add shape, line. Vertical. X is 0, and no, X0 is 2. Oh, there we go. X0 is 1, X1 is 1, Y is 0 and 2, 0 to 2. All right, let's do that. I think it's here. All right, let's add this shape, buddies. Bar fig. Add shape line. It's not going to be from 0 to, where is it going to be? It's going to be on 3. Oof, how are we going to do this via date? Well, we know the y-axis is going to be, let's do it from 0 to 20. That we know. The y is 0, and the second y is 20. But the x-axis, I don't think it's... Let's see what happens if we leave it at 1. I don't think it's going to... I'm sure it's not going to work, but let's see what we get. I'm going to remove... Well, that's fine for now. That is fine. All right. Where are we? Did I do it on the right? No, this is... What am I doing? We're supposed to put it on the... Not in the fig. Not on the bar chart. We're going to do it on the scatter map. Sorry, on the line chart. Right here. Line. There we... Okay. So that doesn't work. It's not 1. It has to be... where's 3, 6? So this will be the first one, second, third, fourth, fifth, 6, 7, 8, 9, 10. I think it'll be on the 10th one. Oh my God. 10 and 10. That's going to be the 10, the x-axis. And I want it... What happens if we do... Let's do it as yellow. There we go. Let's do it up to 40, and we'll do it as yellow. Royal blue, I should call it royal yellow. With 3, align, and up to 40. Oh, and we should put the text near it. We should say the text is a vertical line. Three 3.5, 1.5. No, this is 2 and 1. 2 and 1. There must be an easier way to write text here instead of... There has to be an easier way of writing text instead of doing at traces. There we go. Text, text, text. All right, let's do it. Let's do it the long way. We see that we have here our line, our yellow line, perfect, and we want to call it COVID. Folks, you should be, feel free to join me, ask me any questions. Anything you want. Curious scatter traces of text labels. No, there must be an easier way. Text and let's do an annotation. Annotations. This can't be so complicated. Oh, this is let's do this. Add annotation, the x will be at, what did we say it was 10? But the y will be at, we'll put it at 35 or 30. Now we'll say COVID-19 begun. Or just COVID-19, people understand. Show arrow, arrowhead. All right, let's see what that happens. Let's see what that does. Oof, that looks bad. COVID. Why is it all the way there? Let's see. COVID-19. Why is it all the way there? What the heck? Oh, X is supposed to be 1. I said 1, not 20. What? Okay, let's change that to 5, I guess. 10. 10. Yep, that's what we did here. X10. Not sure why I did it as 20. That was ridiculous. There we go, COVID-19. Let's even move it back a little bit to 9. Comment. There we go, COVID-19. Oh, yeah. We got it. COVID-19. And then we see that animals in the park didn't really change. Actually came down after COVID-19, but food establishment really dropped. COVID-19 is when it started dropping, and it started picking up again here around 2021, like a year later, when restaurants started opening up, and it peaked at 37 complaints in food establishments on March 25th of 2024. So 4 years after the beginning of COVID-19, we see that the peak of food establishment complaints started. Very, very interesting to see the analysis of food establishment or pests in restaurants over time. Obviously, restaurants are closed here during the first year of COVID. Restaurants start opening up in New York City, and then they really hit highs in 2024. And continuing even in 2025, they're pretty high, 33 complaints in February of 2025. I would expect them to be a bit higher in the winter months compared to the summer, but I'm not sure. Yeah, I wouldn't be sure. All right, so we tackled this part, a geographical display of the complaint type and descriptor dominated by zip code. We didn't do it by zip code, we did it by a scatter map like this. We focused on pet animals, and we saw that there's a lot of concentration of them in Manhattan, on sanitary conditions in Dumbo, where you have a lot of restaurants, especially here. Yep. And we saw a bar chart or a histogram of the complaint type versus descriptor. And we also built a line chart of the different complaint types: food establishment, highway condition. Highway condition didn't change over time, and so on and so on. All right, so we have 3 beautiful graphs. Somebody suggested compare the rat sightings day to day and do machine learning predictions to predict where there might be future rat sightings. So we're not going to do it for machine learning right now. It's already been an hour and something. But to compare rat sightings day to day, I'm pretty sure these are right here. Rat sightings of food establishment. But this does it on a weekly basis. We could try day to day. It's not, we can do by, where is it, by day instead of week, we can do by day. Where did we change this? Week type. Here. Period, let's try by week, by day. See if that changes anything. 2020. Oh yeah, we had some negative days. Let's try this. Okay, so this is by day. Let's just focus on 20 to 2021. You see there is at least one complaint in the city. 5. Yeah. It's a lot easier to see by week because these, here there was 12 complaints on March 2021, 11 complaints on July 2022, July, May. The summer, end of spring, summer months seem to be the highest level of complaints. But for me, it's easier to see via week, so we'll just do week. Okay. All right, folks, I'm going to put this code on Charming Data. I'll put it here in the apps with LLMs, AI and LLMs, because we're all going to build an AI out of it later. So feel free to come in here. And then we're going to, later in the week, we'll do more analyses. What's the average time for closing a complaint? And that is a complaint status, right? Status in progress, closed. I don't think. Let's see if we have a closed. Do we have a closed? Yeah, and we have a closed date to 24. Resolution, action, update. Yeah, so we have a closed date, 2027. Or here, close at 2025. And we have an open date, close at 10:05 in the morning, and it opened on 2/13. So actually this took, 12 days to close. Department of Parks and Recreation, Animal in the Park. I wonder why it took them so long to close. But then we'll do this analysis. What's the average time for closing a complaint, and how did it change during this time? Did it take more time to close a complaint in certain parts of the year, or certain months, or certain season? We'll do that kind of analysis. All right, folks, thanks for watching. If you have any other questions you would like to ask about this data set, let me know, and I'll be glad to build a plotly figure trying to solve those questions that you have, or interesting data insights that we can do. Thanks everyone for joining. Always remember, we're better together, so help each other out. And I will see you either tomorrow or in a couple of days. Yeah. Bye, everyone.